Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I'd like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app or trying out something that you find out about on the show. And Linode recently announced an update to their pricing, so you can actually now get a 1 gigabyte server for $5 and high memory plans starting at 16 gigabyte servers for $60 a month. And they've upgraded the storage from 24 to 30 gigabytes for the $10 plan. You can visit our site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. To help other people find the show, you can leave a review on iTunes or Google Play Music and tell your friends and coworkers and share it on social media. Your host, as usual, is Tobias Macey, and today I'm interviewing Francesc Alted about the PyTables project. So, Francesc, could you please introduce yourself?
Hello, Tobias. Yes, of course. I am a freelance consultant and developer. I am physicist by training, but computer scientist by passion. And in fact, I spent most of my life wrestling with computers. I enjoy it so far.
And how did you first get introduced to Python?
Yeah, well, I first heard of Python because an old friend of mine, Vicent Mas, told me about the language. I mean, it was like we were in the 90s by then. And he said to me, well, you should check this language because it's cool, it's new. So I was a user of Perl at that time. And I started to read about Python. And I got hooked immediately on Python. So by the end of 90s, I was learning very, very hard in Python. And then things turned out that starting in 2001, I started coding most of my time, professional time in Python. That's more or less how I got introduced.
And PyTables in particular, I know, is a high-level wrapper around the HDF5 file format. So I'm wondering if you can share a bit about what HDF5 is and what was the problem that you were trying to tackle that motivated you to actually start creating PyTables.
Sure. So HDF5, it's a format, it's a library and also a format, a file format that allows you to store large amounts of data. So I was looking for a solution starting at the beginning of 2000s for storing large amounts of data, multidimensional data, but also heterogeneous data like tables. And I discovered HDF5, which allows you to store multidimensional data, but in a hierarchical way. So I was looking for something very, very close to that. And I started to look into that, and I started to see if there was some kind of wrappers, Python wrappers for it, but the existing ones were not very interesting for me. So I needed something especially faster than what there was at that time, and I started PyTables as a way to wrap HDF5. Also, regarding the capabilities of HDF5, in my opinion, HDF5 has a couple of features that makes it unique among other formats. The first one is that, as I said before, it allows you to endow a hierarchical structure to your data, which is very handy in many cases. So you can just put all your data hierarchically in a file, send this file to another colleague, for example, and he will see the same structure right away. The second amazing feature, in my opinion, of HDF5 is the capability to store data in chunks, what is called chunk dataset. And that allows for a lot of things, but especially two things. The first one is that you can extend your existing datasets in your files, in your HDF files, very easily. Not very easily, but also very fast. Okay, so it's really very, you can get a lot of performance by using chunking datasets. And the second thing that allow chunk datasets is that they allow to compress the data on the fly. For example, if you have a dataset of 1 gigabyte long, you can split it in chunks of, say, 1 megabyte, for example, and then HDF5 will compress each chunk automatically for you. You only have to specify the codec that you want to use, and then HDF5 will take care of everything. And then that also means that when you are storing data on this, and if you use these filters, what is called filters for compressing the data can be compressed before the data reaches to this. And that means that you are writing less information less actual information to the disk because the information arrives in a compressed state to the disk. And then when you are reading, HDF5 will retrieve only the interesting part of the dataset that you requested, and HDF5 will detect which part of the data, which chunks of the dataset it has to decompress, and will decompress the data automatically for you. As the data is compressed, HDF5 will need to read less information from this, and that in the end means that you can get more throughput in the long run if you are compressing the data, because the CPU can decompress data faster than it can be stored on this. So in my opinion, these are this hierarchical way to store data, and also the way to structure the data in chunks, for me are the two killer features of HDF5. And of course, PyTables takes advantage of that. Mm-hmm.
And when you're talking about large data sets, exactly how large? You mentioned gigabyte size data, but I'm wondering what are some of the upper bounds of the actual amounts that you've seen in terms of people using HDF5 and PyTables for?
Yeah. Well, there is a huge variation, of course. I mean, people that just store data which is 1 megabyte or 2 megabytes, since people that is storing creating PyTables files which are up to terabytes of size. So yeah, I mean, there is no upper limit on that. There are other kinds of limitations, like the amount of metadata that you can store per dataset in the hierarchy, but not an actual constraint in the amount of data that you can store. So I don't remember. Maybe the largest file that I've seen in HDF5 is like several terabytes, but it can be larger than that. Mm-hmm.
And does the read and write performance across the data within those large data sets maintain fairly linear as you increase the amount of data that's being addressed?
Yeah, that's a good question. I mean, it's difficult the variation of the range of variation of the data that you can store, it's huge. So depending on how large is the data that you want to store, you may want to use a chunk size for another, because HDF5 keeps an account of the position of every chunk on disk, and that is stored on a tree, okay, in memory. And of course, if you make your chunk size very small, this tree grows grows a lot, and that means that the access to the time to access the data will slow down considerably. So you have to get a balance between the chunk size and the total amount of the data set you are storing. One of the features that I am more proud of in PyTables is precisely this capability to suggest the chunk size that you have to choose. PyTables is choosing that for you by default, so that in case you are storing, for example, a very large data set, like a 1 terabyte data set, then PyTables will choose chunk size which is larger. For example, 10 megabytes. I don't know. I don't remember the details, but let's say that is that. Whereas if you're storing like a data set which is a few hundred megabytes, the chunk size that is chosen automatically by PyTables is probably much less than that, probably 256 kilobytes. Okay, so this capability to automatically adjust the chunk size is something that PyTables implemented the first among in the HDF5 community, and since then other people, other libraries have copied the idea. But this is the main way to allow HDF5 to deal with small and large data sets by computing this chunk size properly. And for this, I did a lot of experimentation. Of course, I spent long time to check the speed access, to write, to read. And after all these experiments, I did some algorithm to predict more or less in a trusty way, more or less, which is the chunk size that is optimal for the data set.
And for the input to that algorithm, do you request that the person using it estimate the amount of data that they're going to be working with, or is it possible to rebalance the chunk sizes after it's already been written to disk?
Yeah, I mean, at the beginning, if you don't know, I mean, PyTables has no way to know how large the dataset is going to be because the datasets are enlargeable, okay? For enlargeable datasets, PyTables has this flag, which is asking you the number of rows, for example, in tables, that you plan to store that. So this is a way for PyTables to know which will be the final size of the dataset. For datasets that are fixed in size, there is no need for doing that, and PyTables just will take the final size because it is going to be known at the creation time, and it will adjust for that size. So yeah, I mean, PyTables is asking the user how large is going to get to be the final dataset.
And one more question about the sort of technical aspects of HDF5. I'm wondering if it's primarily a row-oriented or a column-oriented file format, because I know that you have different trade-offs and capabilities based on sort of the dimensionality of how the data is addressed, particularly in terms of being able to compute space and computation savings with column-oriented data, since all of the data types in that given column are known, and so you can get some optimizations as far as addressing all of those in the same manner.
Yeah, that's a very good question, and this is a question, a subject that I am putting a lot of time lately. HDF5 is basically agnostic about the order you are storing the data. So HDF5 is about storing multidimensional data sets. What you can do is to specify in the chunk the shape, the dimensions of the chunk. So for example, if you are storing like a big mesh of 1000 by 1000 by 1000, you can say, you can tell to HDF5, well, the chunk size of the chunks will be like 32 by 32 by 32. So it's the user who specifies how he wants to access the data. This distinction between column-wise and row-wise, it is not directly applicable to HDF5, except in one situation, which is when you are storing heterogeneous data sets in HDF5, or what is called compound types in HDF5. Compound types are basically made of simple types that are like integers, floats, strings, things like that, and you create a compound type by putting together several of these simple types. Like, for example, if you are creating a table with 3 entries, integer, floats, strings, so you will have a heterogeneous data type which is made of integer, float, and string. And of course, the way that the HDF5 is storing that is in row-wise, okay? Because the D type is the way, or the minimal amount of data that HDF5 is going to put together. In PyTables, for example, this specific data type, the compound data type, is very, very important, and it is called PyTables for a reason, because we are using heterogeneous or compound data types all the time. And by default, PyTables is going to create tables that are stored row-wise. Okay, so for a long time I was wondering about, instead of storing tables in terms of compound types, what about creating a single data set per every column, and then store every column in a group, for example, which is the equivalent of a directory in the hierarchy in HDF5. And then in this way we will have a table that is stored column-wise instead of row-wise. In many situations, column-wise access is much better than row-wise. So it depends on the use case. But column-wise has mainly a couple of advantages over row-wise. So the first advantage is that it is possible to add columns very cheaply, because it's just a matter of adding a new data set to the group, and then you have a table with a new column. Whereas if you have the data stored in row-wise, creating a new column, adding a new column to this table is going to require a complete copy. Okay, so this is a very, very expensive operation, copying the data. The second advantage for going column-wise is that as you are compressing the data, if you order your data in a column wise, you are saying, well, this column is going to be in a single data set, this other column is going to go to another data set, and then the chunks are made of elements which represent the same characteristic. Okay, and these values typically has a much less variation than the values in the same row. Okay, so storing the data in column wise has the added benefit that the entropy of the values per column is much less, and then the compressors can go faster and can compress better. And that also means that you can get much better performance. Okay. So having said that, I had a plan to implement column-wise tables in PyTables, but and I tried to get some fundings for that. But in the end, I didn't succeed to get that, and there is no support for column-wise tables in PyTables. But this doesn't mean that it is not a good idea. I think it's a good idea. The problem is a problem of open source.
And on the subject of open source, I know that it's always a challenge to attract enough attention to a given project to be able to increase the bust factor of the maintainers. So I'm wondering what the level of contributions you've seen for PyTables looks like and what your interaction patterns look like for being able to develop the project in a cohesive manner.
Yeah, I mean, this is the main question when you are developing open source is how you can attract developers and how you could create a business model around open source, right? For the PyTables, things were, well, at the beginning, I put a lot of time. It started as a solo project, but then I joined forces with other guys. But all of the fundings came basically from us. But soon in time, the HDF group, which is the creator of the HDF5 format, gave us some contracts to implement some features that their clients needed. So this allowed us at the beginning to work for that. Then we spent like a lot of time developing a new feature, which is, I think, one of the most important features of PyTables, which is indexing. So this capability where you have a big table and you index several columns and you can do queries. And if you are indexing the query, then the query time will be much less. It's exactly the same concept as in relational databases. And we try to sell this product as closed source, as a professional version, so to say, of PyTables. We did that. We spent like a couple of years trying to get this special version of PyTables. But in the end, we didn't sell license enough in order to keep our company alive. So we had to stop basically PyTables development. So after we closed this company, I decided to open all the things that we developed for being the professional version of PyTables, which is basically the indexing capability. And then I decided to drop also support on PyTables because, I mean, I started PyTables like in 2002, and then in 2011, it was like, it was 7 years working on that, or no, even 9 years working on that. Oh my God. And then I decided to change subjects. And I announced that I was going to drop the maintenance of PyTables. Unfortunately, open source allows this kind of people saying, hey, I am a big fan of PyTables. PyTables cannot die. I am going to take the maintainer hat. And it was then when Anthony Skopacz jumped on the scene. He get the PyTables and did a lot of the documentation. He did a new version of the documentation, very, very tough work. And yeah, I mean, he pushed PyTables a lot. I am very grateful to him. And also Antonio Valentino, he was doing a very nice work. I mean, he started contributing things to PyTables very early, like in 2007. And other developers that joined the crew were, well, Ivan Vilata joined me for creating the company. He did outstanding work on PyTables. And lately, we have also new people that is joining the crew, like Andrea Bedini, which is an Italian guy, but who was working in Australia. And he did very nice contributions lately to PyTables. I am also more or less back. I try to get on top of that. And Andrea, for example, organized a nice hackfest past year in Australia. And we got developers from all around the world, people from the US mainly, me and he were joining in Australia for creating a new version of PyTables. Unfortunately, we didn't have time in just 1 week for doing that, but the code is there, is in a branch, and perhaps we can find the opportunity to finish it. And finally, also we had the opportunity to meet Tom Koigi. I think he's from the Netherlands, and he is also the new maintainer of PyTables. So yeah, I am very happy that open source is a big community, and by opening your code, you will be able to make your ideas to spread more and to be much more maintained. I don't know if that was the question.
That did a good job of answering the question, and it gives a lot of interesting and relevant backstory to the project as well, which is one of the most rewarding and most interesting aspects of doing this show, is being able to understand the story behind the project, even beyond just the technical aspects of it. And speaking of the technical aspects, I'm wondering what the underlying architecture of the project looks like, and some of the design choices that you're most particularly proud of, or also alternately frustrated by.
Yeah, that's a good question. There are many things that I am proud of the design. Perhaps one of the most basic ones, but I think it's the one that I love the most since the beginning, is this natural naming capability. So natural naming accounts, it's a feature that allows you to access a data set in the hierarchy by just putting a dot in a class. So for example, when you open a file, in a PyTables file, you get an object, and this object, inside this object, there is a special object attribute which is called root. And root is the object that contains the hierarchy in HDF5. So after root, you can access, for example, a dataset which is called, like, for example, detector, and you can say, well, f.root.detector, and then you are accessing the dataset in detector. Okay, so you don't need to say like f.getNode at f and it's called a detector. So this capability of accessing the datasets just by accessing attributes in objects means that, for example, if you're using IPython, the IPython shell or the regular Python shell, you can by just using these objects f.root, and then you can put like another dot, and then if you press tabulator twice, you will get a list of the datasets that hangs from root. Okay. Or if you are going more into the deep in the hierarchy, you can specify root.group, which is a directory, dot, then hit tabulator twice, and you will get the list of children that hangs from this group. So this allows you to navigate very easily in the hierarchy of your dataset. Probably this is one of the features that I am more proud of. It's very simple, but it's no other library has this capability. Also, of course, another capability that sets PyTables apart from other solutions is the indexing capability that I mentioned before. So this capability of taking a table, okay, and create an index of a column, and then being able to issue a query on this table. And if the column that you indexed participates in the query, then the time to get the result is going to be much short. So when you have tables that are terabytes in size, this capability is critical. And in fact, in my opinion, this single capability is the responsible, or is the reason why the Pandas developers have chosen PyTables as the HDF5 backend for Pandas. Probably you know, or the audience know what is Pandas, but Pandas is a killer application that many people is using for doing data analysis in Python, in the Python ecosystem.
Yeah, I was going to say I'm actually going to be interviewing one of the maintainers for that project for next week's episode, so stay tuned.
Okay. Is Jeff or Wes McKinney?
Jeff.
Jeff. Okay, excellent. And yeah, but probably, well, there are more things about PyTables, but I am not going to get to bore the audience anymore. But I think these two are the most important ones. Regarding the things that I am not very so proud of, is also this natural naming feature also brought some complexities in how the hierarchy is stored or is managed internally in PyTables. And it's managed like trying to emulate the hierarchy in form of hierarchy of objects. And sometimes the relationship between objects and how you access objects in the hierarchy is not trivial, because it's very easy to create loops between these objects, and sometimes these loops can create memory leaks, and debugging these memory leaks was not fun at all. I spent tons of time trying to get these leaks out of PyTables. But anyway, right now, more or less, the leaks are not existing anymore, but of course the code is a little bit too messy in many aspects, in many places. Also, I am not very proud of the way how iterators are implemented. I am a big fan of iterators, and all of the datasets, HDF5 datasets, can be iterated, but the way how I implemented iterators was in a non-stateful manner. So that means that depending on how you iterate the table, it can give you a result or another. So, the environment in which you create or you invoke the iterators is going to affect the result. And this is a tricky thing that we try to solve it, but it's not easy to fix. We would appreciate if someone jumps in and try to fix this iterator issue. And this is one of the two things that I don't like very much. Yeah.
And what are some of the typical use cases for PyTables? And also, I'm curious how it ties into the broader Python data ecosystem. I know you mentioned that it's used as the backend for pandas to access HDF5 files, but I'm just curious how it also relates to some of the other aspects of the larger ecosystem of Python for data analysis and data science.
Probably PyTables right now is very known because it is the HDF5 backend for pandas. Interestingly enough, pandas didn't exist when I created PyTables. PyTables was created 10 years before pandas. And of course, my intention for PyTables was to serve as a way to store mainly scientific data, but also data coming from computers from sensors, for example. Okay, but pandas is used a lot in the financial world. Many people in the financial world is using PyTables because it is the backend, one of the backends of pandas. So as a consequence, the financial world is using PyTables a lot via pandas, and also in a standalone mode, there is a lot of interest in using PyTables. And my main interest at the beginning was that people in science and other industries were going to use PyTables as well. So at the beginning, especially many universities, when people is doing PhDs, they are fighting with technology, and they are willing to adopt new technologies very soon. So people at the university, especially PhDs, were one of the first users of PyTables. And many people started, for example, there was a guy in University of Berkeley, I think. He had like a device for tracking the flight of flies. I don't know. And all these tracks of the flight were stored in HDF5. And then people from the industry, like another guy who asked me to tailor PyTables because he was using it for storing the results of a simulation program for hydrodynamics, I think, and he wanted me to tailor, or wanted us to tailor the behavior of PyTables specifically for that. So yeah, people at the beginning from the university, then also from companies, especially in research, and yeah, in the last years, in the later years, mainly, I would say that PyTables is mainly used in financial applications, which was absolutely not the first thing that I had in mind at the beginning, but life is like this, and you get surprises all the time.
Yep, absolutely.
Mm-hmm.
It's always amazing to see the uses that people will put something to that were beyond the initial ideas or even intended capabilities of the project at the start.
Exactly. Yeah, very true.
And I know that you mentioned one of the original appeals of HDF5 as a file format was particularly for data interchange, for sharing between researchers, and also for data archival.
Mm-hmm.
I'm wondering if the particular approach to data formats that PyTables uses complicates the ability to use those resulting HDF5 files from other languages or other libraries.
Well, this is not an easy subject. PyTables is using HDF5, to store everything, except for one single thing, which is when you are trying to store data that has not a simple translation to HDF5. So, for example, when you're trying to store like a complex Python object, PyTables, what it's doing is to serialize this object using pickle. Okay, so pickle creates a big string out of the object, and then PyTables store this pickle string into an attribute of HDF5. So then, if you do that and you try to open this HDF5 from a language which, for example, can be Julia, for example, of course Julia doesn't understand the pickle format, right? And Julia will not be able to get this attribute out of the HDF5. However, if you take attention, you may read into the description of the format, which is Appendix C or Appendix B in PyTables documentation. It is exactly documented where PyTables is going to use a non-standard HDF5 format for storing data. So if you are conscious about that, and you try to avoid storing like exotic data that cannot be translated easily into HDF5, you shouldn't have any problem into read these datasets from other languages. Okay. Also, PyTables makes use of meta information for describing things like indexes in tables, things like that. This is a specific feature of PyTables. Of course, HDF5 doesn't support indexing per se. Indexing. Okay. So although you create a table with an index in PyTables, you will be able to retrieve or to read a table, for example, from R, from the language R, but you will not be able to use the index that accelerates the query. Okay, so yeah, PyTables add some sugar, syntactic sugar, or not syntactic but semantic, more properly, on top of the data. But if you want to be like completely portable, you still can do that in PyTables. You just don't use the more advanced features that PyTables offers. So it's perfectly possible to create HDF5 files that can be read by other HDF5 applications in any language or in any application. No problem with that. But you have to know about the intricacies of how PyTables store the data.
And one thing that you mentioned briefly in there that we haven't touched on yet is the querying capabilities of PyTables. And I know that in the documentation, there's a bit of a tutorial of how you could map the concepts of SQL onto the querying capabilities of PyTables and HDF5. So I'm wondering if you can just briefly touch on that.
Yeah, since the beginning, we wanted PyTables to excel in storing tables and doing queries. And one of my coworkers, Ivan Vilata, had this idea of saying, well, if we want to make people aware that PyTables can do queries in a close or in a similar way than a relational database, why not doing a tutorial on how to match the different way to do queries between relational databases, SQL, basically, and PyTables. And yeah, I totally agreed with him, and he put some time to create this tutorial, and I think it's very nice for people that is used to handle handle or to use SQL all the time, how these SQL queries can be translated into Python or PyTables specific way. And yeah, for example, the main thing that you can do in PyTables that is similar to SQL query is the table dot, I think it's query, I think it's the method, I don't remember now exactly, where you can specify the condition and then the starting row, the end row, and things like that. But the query is not the only and then you can also do like indexing, and you can also do sort bys, group bys, but by combining PyTable machinery with Python machinery. There is a way to combine that can reproduce the behavior or sort by or group by in SQL. And this is why this is what is written in the tutorial, how to map or how to reproduce the SQL query language in PyTables and also Python using PyTables and Python machinery. I think it is a very nice tutorial.
And as you've mentioned before, the original work with PyTables was started several years ago. And in recent years, in particular, there's been an explosion of new data formats and serialization formats as the overall industry of data analytics has become more prevalent. So I'm wondering how the position of HDF5 and PyTables has changed in relation to those other capabilities, and what are some of the features that PyTables offers that aren't easily replicated in some of these other file formats or database systems?
That's a good question. I mean, we are indeed in the big data age, and this is showing in the amount of new databases, new formats. I mean, this is not something that is happening now. I mean, that happened like all the time. I mean, in the 80s, 90s, 2000s, there were like a myriad of different formats. Probably nowadays, this is even more visible because data is now the big player. I mean, before the code was probably more important than data because computers were not very capable to store a lot of data, and the way to store the data was like probably secondary. Right now, in my opinion, the big change is that data is critical. I mean, data storage. How do you store the data? Which containers do you use for the data? And of course, I mean, there are many different ways to approach the data analysis, and there should be. I mean, we need a lot of different tools to analyze and especially to store the data. This is not going to change. HDF5, in my opinion, continues to be a very nice way to store data. It has its own use cases. You cannot go much further than that. But in my opinion, for storing like high multidimensional data and for storing big tabular data, it's still a very nice solution, especially because of the on-the-flight compression, and in the case of the PyTables, because it can index very large tables exceeding the limits of the memory. I mean, the indexing happens on this, right? It's like a relational database. But contrarily to relational databases, tables can be stored much more efficiently in HDF5 because compression can be used. And this for big data is really critical. And I still see a big niche for HDF5 and PyTables in particular for storing large amounts of data, especially in tabular form. But of course, other solutions like Hadoop or I don't know, Thrift or other ways to store data are completely okay. I mean, it depends on your data access and your needs.
Yeah, I think that one of the unique aspects of HDF5 still is the ability to have everything self-contained in a single binary file that you can transport to different machines and different systems versus a more network-oriented file storage such as HDFS or, a Cassandra database or anything like that.
That's exactly true. And I would say more. I mean, HDF5, the HDF group, the people who is behind the HDF5 development, is very conscious about long-term usability of these files. So besides of this capability of being able to share easily your data, you can trust that HDF5 you will be able to read HDF5 files in like 10 years or 20 years from here, right? Behind HDF5 is the HDF group, who is sponsored by many public laboratories, like especially NASA, for example. NASA has most of its data in HDF5 format. And NASA, of course, doesn't want that in 20 years, they won't be able to read the information that has been stored for, I don't know, for the Hubble telescope, for example, or for the many satellites that are taking pictures of the different aspects of Earth, right? So this is also very, very, very important, and it is one of the main strong points of HDF5. I agree. Mm-hmm.
One of the really interesting capabilities of PyTables that I came across while I was going through the documentation is the undo and redo options that you expose. I'm wondering what a real-world use case for that might look like.
That was a requirement of a company because people that do open source typically achieve to survive from people that want to tailor the behavior of your libraries and pay you some sums for doing that. So a company asked us for a way to be able to store some datasets, to create some datasets in some groups, and then undo these operations later on time. I think their use case was that they were doing simulations that took a lot of time, and sometimes the simulations went into the wrong way, and they had to go back and start a new simulation, a new branch of the simulation from another earlier point, and they want to basically undo all the modifications that they did in the original simulation branch. And we implemented that, and we were very, very proud of how we implemented that, because it was basically a log of the actions. So all the actions that were created from some checkpoints were logged into a specific table inside an HDF5 table, and then when the user wanted to go back in time and undo the actions, it was just a matter of recovering the actions in the log, and then undo the different actions. That was the use case. I don't know if this feature is used a lot in the industry, but that was the main reason why we included it. And it's probably not used a lot, but it's a nice feature at least.
And you've touched on a few different interesting and unexpected uses of PyTables that you've encountered, but I'm wondering if there are any that stand out in particular to you that you'd like to share with the audience.
I mean, something that I didn't mention a lot is, well, I do mention the compression capability, right? So somehow I got very interested in this compression stuff, and I started developing a new compressor especially for PyTables that was going to be very fast, although compression ratios were not so good as, for example, zlib or just which is the default in HDF5. So I started to create a codec specifically for PyTables, which I call BLOSK. And BLOSK is a compressor that can do multi-threading. I mean, you can use several cores at the same time for doing the compression, and also implement specific versions of filters that existed in HDF5, like the shuffle filter. I did a implementation of that used the simple instruction multiple data instructions that are in modern CPUs, Intel CPUs, like the E2 set of instructions, or more recently AVX2 set of instructions. And in combination, the new codec, and also, well, the codec BLOSK is not exactly a codec, it's a set of metacodecs. So you can use different codecs inside BLOSK. So you can use, for example, LZ4, which has a lot of reputation for being very fast. And lately I added also set standard, which is also reaching very good decompression speed and also very nice compression ratio as well. So you can use all these codecs inside from BLOSK, plus the capability of using very optimized shuffle. With that, PyTables is able to compress and decompress really, really much faster than any other codec that you can see in other solutions, in other libraries. And lately, you can use BLOSC even from directly from HDF5, because the SDF group implemented what they call the dynamic filters. And with that capability, you can use BLOSC also inside any HDF5 application. But I think this BLOSC capability is also a very strong point of PyTables, and lately also strong point of HDF5 in order to get the best performance as possible.
And are there any other topics or questions that we didn't touch on yet that you think we should cover?
I think we touched basically the main points. Yeah, I just want to say that PyTables is still a live project, so it is mainly in maintenance mode. That means that we don't introduce new features or no new very shiny new or very interesting features, but we still do a maintenance of it. And we want to keep PyTables safe and safe to use for the next 10 years.
And one thing that we didn't mention yet is that it's currently maintained under the umbrella of the NumFocus organization.
Yeah, that's a very good point. Yeah, I forgot to mention it. Yes. So 2 years ago, as I said before, Anthony Skopats was taking charge of PyTables, and he did a lot of push for PyTables, and he achieved that NumFocus accepted PyTables under its umbrella, and it's a very good news. Thing is that not many companies use this opportunity to sponsorize some features or some maintenance. But I encourage anyone that is listening at this that they can put money into the NumFocus organization in order to implement or to enable more maintenance or more new capabilities in PyTables. It is a very nice umbrella organization, and hopefully we will receive some benefits in the long term. Thanks for the reminder.
And for anybody who wants to follow what you're up to and keep in touch with you, I'll ask you to send me your preferred contact information, and I'll include that in the show notes. And with that, I'll move us to the picks. And my pick this week is a movie that I watched recently called The Accountant with Ben Affleck and Anna Kendrick. And it was a really well done movie because it was an interesting take on the typical action film where the main character was actually high functioning autistic. So he was in some ways similar to the idea of Rain Man as far as the mathematical of aptitude, but it's taken in a very different approach where the main character is an accountant for, I guess, the shadier aspects of civilization, but he also has a very strong moral compass and uses his access to these different organizations to help the Treasury Department prosecute a number of these cases. So it was an interesting movie, had a lot of thoughtful pieces to it, and I thought it was very well done overall, so I definitely recommend watching that. And with that, I'll pass it to you. Do you have any picks for us this week, Francesc?
Oh yeah. I've just seen this new movie, Batman, the Lego movie. Wow, that was really a very nice movie. It's I don't know, it's very entertained. It's the action is non-stop action, a lot of jokes. It's if you want to spend like a couple of hours laughing and feeling much better after seeing the movie, I highly recommend this movie. Mm-hmm.
Yeah, that's one that's definitely on my list to watch pretty soon. So I've heard good things about it already, and that just confirms it even further that it's definitely something to find some time to watch soon.
Pretty amazing.
All right. Well, I really appreciate you taking the time out of your day to join me and talk about PyTables and HDF5. It was quite interesting. I learned a lot in the process, and I'm sure that a number of the listeners will find it interesting as well. So thank you for your time.
Thank you, Tobias. Bye-bye.